So the work done is stored either the expression for the work done we calculated is maybe CV square, maybe 1 by 2 QV, maybe Q square by 2C, depending upon the statement or the condition. I will use these formulas. So one thing is clear, that if I plot the graph between V and Q, charge and potential, and give I get a straight line for this Q equal to CV. So if I drop a perpendicular and find its slope, then Q equal to CV, so slope will give the value of C. But if I find the area of triangle OAB, area will be 1 by 2 base into, so this is what, this is the energy stored in capacitor. So sometimes question पूछ सकते हैं, तो what does its area represent, तो you will write the energy or the work done to charges. Next term that comes in our mind is about common potential. Common potential. अब हुआ क्या बच्चे, मेरे पास दो कंडक्टर थी, इसकी कैपेसिटी थी बच्चे C1, इसकी C2, इस पे था V1, इस पे V2. So before this I discuss another very simple concept of 9th class, that there are two beakers. These two beakers are connected by a pipe. This beaker is empty, but this beaker I filled with water full up to height, full height filled with water. What will happen? There is a tap. If I open that tap, what will happen? The water will flow from this side to this side. Up to what time? Up to what extent? Till both attain the same height. Here I suppose there are two conductors of capacity C1 and C2. One is V1, and I suppose that V1 is greater than V2. If V1 is greater than V2, it means it is at high potential, but this one is at low potential. The charge will flow from high potential to लो. कब तक? जब तक दोनों का पोटेंशियल क्या नहीं हो जाता, सेम. दैट सेम पोटेंशियल विच अटेन्ड by these two conductors is called common potential. Clear this? What is common potential? So before connecting with each other, what was total charge? C1 V1 plus C2 V2. What will be total charge after connecting? After connecting, now charge becomes C1V plus C2V. Why it is V? V is the common potential which these two conductors will attain. When once these two conductors attain common potential, there is no transfer of charge. According to conservation of charge can neither be created nor be destroyed. These two must be same. It means C1V plus C2V, C1V1 plus C2V2. Take V common, inside you get C1 plus C2. So V comes out to be C1V1 plus C2V2 divided by C1 plus this V. This V which is called common potential. One thing more you have to remember, that capacitor before connected, like it's not connected, is C1 V1 C2 V2. Now before connecting, its energy is given by half C1 V1 square, half C2 V2 square. But when you connected, both will attain the common potential. But when you connected, both will attain the common potential. Now you calculate the energy, it comes out to be half C1 V square, half C2 V square. And if you solve this derivation, you get, after solving, half C1 C2 C1 plus C2 V1 minus V2 ka whole square. After solving, if you take the difference, this quantity is always greater than 0. It means I prove that E1 minus E2 is greater than 0. This implies E1 is greater than, it mean what? It mean there is a loss of energy on sharing. there is a loss of energy on sharing. You have to remember this. There is a loss of energy on the sharing. Clear this? So this is regarding this. Now next after this the question that come in mind, that is about dielectric. The last topic of this capacitor is dielectrics. So dielectric are the substances which do not allow the flow of charges through it, but permits them to exert electrostatic force on one another through it. It means the charge cannot pass through the dielectric, but it transfers the electric effect without conducting itself. So dielectric, once again I repeat, dielectric is a substance which transfers the electric effect without movement of the charge carrier inside it or without conducting itself. Dielectric is made up of two types of molecules. One is polar molecule, another is non-polar molecules. You have studied in chemistry also. Polar molecule in which center of positive does not coincide with the center of negative. It means each of the polar molecule behave as a dipole, electric dipole. Each is behave as a electric dipole. Its example is water, HCl molecule, carbon monoxide, etc. Once there was a question in CBSE, name the dielectric whose dipole moment is not zero. Polar dielectric which are made up from polar molecules are those dielectrics whose dipole moment is not zero. Why? Because in positive it does not coincide the process net dipole moment, which is given by Q into 2A. On the other side, what are non-polar? In which positive coincide with the center of the negative. It means in this case net dipole moment will be zero, since there is no distance coincide with each other. So in which the center of mass of positive charge coincide with the center of mass of negative charge, such type of molecule is called non-polar molecule, and dielectric which are made up from these types of molecules are called non-polar dielectrics. And example, H2, N2, O2, carbon dioxide, etc. This is the example. Clear? So very important, dielectrics. Now let us see what happens when I place these two types of dielectric in external electric field. Let us suppose, next question, next heading is effect of external electric field on dielectrics. Effect of external electric field on dielectrics. First I am taking बच्चे polar dielectrics. Let us take a slab of polar dielectric. Now in this polar dielectric we have positive and negative which do not coincide. All molecules are randomly, और कोई इधर जा रहा है, कोई उधर जा रहा है, कोई बच्चे इस साइड है, कोई इधर डायरेक्शन में, हर कोई randomly oriented in different direction. But one thing is clear, if I find the net dipole moment, answer will be zero. The question comes, sir, why it is zero? Because dipole moment is a vector quantity. We have defined direction from negative to positive. So once you calculate the net dipole moment, maybe इसका इसको cancel कर रहा है, इसको cancel कर रहा है, और net moment क्या आ रही है बच्चे मेरी zero. After this, what they did, they applied the external electric field. One is positive side, another will be negative. Now what will happen? What will happen that this positive will try to negative attract positive, attract negative, positive, attract negative. Or we can say each dipole will experience the torque and try to rotate in the direction of electric field. So after introduction, after applying this, the alignment will be like this. Positive है तो this side बच्चे it will be positive, then this side will be negative, negative, positive, negative, positive, negative, positive. These are dipoles. This side is negative, positive, negative, positive, negative, positive, negative, positive, negative. It means the one side, you can see this side, negative will appear on this side, but this positive, negative will cancel out each other. The process of inducing the charge on the surface of dielectric when placed in external electric field is called polarization. What is polarization? The process of inducing, देखो बच्चे, inducing charges on its surface. When किसके surface पे? Dielectric के. When placed in external electric field. जब external electric field में बच्चे रखता हूँ, उसके surface पे जब charge induce होते हैं, this process is called polarization. Clear? This is the case when I place the polar. What will happen if I place non-polar? Non-polar में तो बच्चे टॉर्क भी लगेगी. क्यों? क्योंकि उसकी नेट डाइपोल मोमेंट क्या है? जीरो है. पॉजिटिव नेगेटिव coincide with each other. So even if you apply the electric field, the net dipole moment is zero. But what will happen? Let us see. When you keep applying this electric field, what will happen? That due to this electric field, the negative will try to attract toward positive, or we can say positive will repel. After increasing the magnitude of electric field, a time will come when the charge will shift by some distance, little distance. But once there is some small distance, then non-polar becomes polar. And it will behave same as that of the previous one, this one. So what is difference between these two? The only difference in this case, we applied more electric field as compared to this case, because in this case already it behave as a dipole and a torque will act p sin theta in the direction of electric field. But in this case, first I will apply the electric field to make non-polar to polar. And once non-polar becomes polar, then the rest will be same. So more electric field required in this case as compared to this case. And this phenomena of inducing the charges is called, it is called what? It is called polarization. Thank you.